Andrew.
I'm Lucas.
And today we're going to be explaining the physics components behind a guitar. Alright. To start off, we're going to be talking about the guitar components. So come closer. First are the tuning pegs. Here you tighten and loosen them to control the pitch of the string. The tighter they are, the higher the string will be. The looser they are, the lower the pitch will be. Now, for the strings. A standard guitar has 6 strings. The first string is the low E string. Second is the A string. Third is the D string. Fourth is the G string. Fifth is the B string. And sixth is the high E string. They have varying thicknesses which affects the pitch. Next are the frets. On a guitar, there's around 20 something frets. I'm not 100% sure, but you don't really use the bottom ones as much. But what's important about the frets are that they control the pitch of the strings. For example, let's use the high E strings as an example. Playing the high E string open, you hear it, right? It's already a high pitch, right?
Yeah.
But let's say we press down on the 12th fret, which is right here. Now let's play it. You hear how it's higher? Depending on where you place your fingers on these frets, it controls the pitch of the sound.
Yep.
So next is the guitar body. Standard acoustic guitars are made out of wood and they're wide like this. This is because the guitar has a hole in the center to allow the strings, when being played, it allows the sound to reverberate around the inside of the guitar. Next is the bridge. The bridge, its only purpose is to attach the strings to the body of the guitar. And that's it.
Thanks, Andrew. You're right. The tuning pegs change the tension in the strings. What this means is that the looser strings have far more ability to move when touched. This results in a higher wavelength and a lower frequency, which causes a deeper sound. In contrast, the tighter strings can't move around as much, and so they produce shorter wavelengths and a higher frequency, resulting in a higher sound. Next up is the strings. The strings all vary in thickness, and with the thicker strings producing a deeper sound while the thinner strings producing a higher one. This is the result of the thicker strings having a higher mass than the thinner ones. What this means is that when applied with the same force, the thinner strings will vibrate far more than the thicker ones. Because they're vibrating more, the thinner strings will have a higher frequency, thus emitting a higher pitch. After that, we have the frets, which allow you to further control the pitch. By pressing down on the fret lower to the bridge, the string produces a higher sound than if you were to higher up or not at all. Like the tuning pegs, the frets control the amount of freedom the string gets to move. The more freedom the string has, the larger the vibrations, which results in a lower frequency, which means a lower sound. Finally, we have the sound hole. The sound hole acts as the opening that leads to the inside of the guitar, which is hollow. This allows the sound to reverberate around in there and get magnified due to constructive interference, resulting in a louder sound. And that's about it. Thanks for watching.